Hi again, and our last topic in this chapter has to do with average cost equaling marginal cost. Average cost has critical points when the average cost and the marginal cost are equal. Average cost equals marginal cost, critical point. We can say that the cost to produce Q units would be the fixed cost plus the variable cost, which is true. If you have rent and you have the things that are always fixed, there we have to add those in. And then the variable cost is as things change, like my payroll might be different this week if I had some people working overtime. And the average cost is equal to the total cost divided by quantity. That's what average means. It means the total of everything divided by how many things you have. Marginal cost is basically the derivative. And it's the change in cost of producing one more thing. So for example, I start here with AC equals C of Q, which just means cost is a function of Q divided by Q. Now, if I want to take the derivative of both sides, it's going to be the quotient rule. My F, I have C of Q, which is just a function of Q, but that means that F prime is equal to C prime of Q, the derivative of the cost. And I could say that G is equal to Q, and the derivative of G with respect to Q is equal to 1. And now I can use my quotient rule, which is F prime G minus G prime F over G squared. Now we have A C prime equals F prime, which is the derivative of the cost, times G, which is the quantity, minus the derivative of the quantity, which is 1, times the cost, divided by G squared, which is Q squared. Next step, I can say that AC prime, or the derivative of the average cost, is equal to C prime is really the marginal cost times Q minus the cost, divided by the quantity squared. Now my next step, AC prime, or the average cost, the derivative of the average cost, is equal to MC, marginal cost, and I'm going to separate this one fraction into two fractions. This gives me, I can cancel one of the Q's. I get marginal cost over Q, quantity, minus cost over quantity squared. Now I can say this derivative is equal to 1 over Q. I'm going to factor the Q out, times the marginal cost minus the cost divided by Q. And remember, the next thing we have to do is set it equal to 0, because we're trying to minimize the average cost. To find critical points, I set the derivative of the average cost equal to 0. that equals 1 over Q times marginal cost minus the cost divided by Q. Now I have two functions multiplied together that equals 0. And I know for sure that 1 over Q cannot be equal to 0 because there's no value of Q I can put in there to make it equal to 0. So that means that 0 has to equal MC minus the cost over the quantity, which again means that the marginal cost is equal to the cost over quantity. And if we look back here, the average cost is equal to the cost over the quantity, which means I can say that the marginal cost equals the average cost at my critical point. Which means that when the marginal cost equals the average cost, I either have a maximum, I have a minimum, or something is undefined. That's what a critical point means. But that's my place that I'm going to look. Example 5. The cost in dollars to produce Q gift baskets is given by C equals 160 plus 2Q plus 0.1 Q squared. Find the quantity where the average cost is minimum. Well, I have my cost. I need to take the derivative of my cost. That's going to give me my marginal cost. That equals, well, 160 is a constant. It just goes away. Derivative of 2Q is 2. And the derivative of 0.1 Q squared is 0.1 times 2, or 0.2 Q. Now remember, what I want to do is I want to set marginal cost equal to the cost function divided by Q. So we don't have to do all the work. We can just say marginal cost equals the average cost when the average cost is minimum. I have marginal cost, which equals 2 plus 0.2 Q, is equal to C of Q, 160, plus 2Q, plus 0.1 Q squared, divided by Q. And what we want to do is we want to find the quantity. So we're trying to find Q when this occurs. And it's just some algebra now. I'm going to multiply both sides by Q. That means this Q will cancel with this. And I'll have 2Q plus 0.2 Q squared is equal to 160 plus 2Q plus 0.1 Q squared. Now I have to set all this equal to 0 because this is a quadratic. Whenever I have a quadratic, I have to get all the terms on one side set it equal to 0 and try to factor if I can factor, or use a quadratic formula if I can't factor. So we're going to get everything over to the left, which means I have 0.2 Q squared. Next, I'm going to subtract minus 0.1 Q squared plus 2Q minus 2Q, and the last thing I have to do is subtract 160. That equals 0. Simplify, I get 0.1 Q squared. The middle term cancels. Minus 160 equals 0. 0.1 Q squared equals 160. Divide both sides by 0.1, which is the same as 1/10, which means I get Q squared is equal to 1600, which means that Q is equal to 40. Let's see what that means. The cost in dollars to produce Q gift baskets is given by this. Find the quantity where the average cost is minimum. The quantity where the average cost is minimum is 40 gift baskets. Thank you so much for watching. And that concludes section 2-9, which is optimization applications.